Another way that you can look at the spread of a data set is by creating something called a box and whisker plot. It shows the variability of a data set on a number line. And we used 5 points to create the box and whisker plot. We used the greatest number. We use the least number. And what we call quartiles. Quartiles divide the set into 4 equal parts, which would make sense if you know your roots and prefixes. Quartile has to do with quarter, which means 4. Now, the median is the halfway mark. You should already know that, right? But what we do is we call that Q2, quartile number 2. That's a Q, capital letter Q. And the median of the lower half is called the first quartile. We call that Q1. And the median of the upper half we call the third quartile, because Q2 is already taken by the median. So that's called the third quartile, Q3. So you've got this nice picture. You can see how it shows that the data is spread out on this number line, and the 5 numbers that we use are sometimes called the 5-number summary. Okay, let's make one. This list of numbers represents the ages of the members of a backpacking expedition in the mountains. So the first thing that we have to do is put the numbers in order, because the box and whisker plot is created by using medians. All right, the easiest ones to find now that it's in order are the smallest and the largest. The next one that we're going to find is the median. So we have an even number of items, and in the last lesson when we talked about having an even number of items, we said that the median would be halfway between the 2 in the middle. So if you figure out the 2 that are in the middle, it is right here. So I don't actually even need to average anything. The median is right here at 25, right? Because it would be 25 plus 25 divided by 2. Now what I'm going to do is, using the values right here, not including the median, I'm going to look for the median of the lower half. That's the first quartile. So the first quartile is right here at 23. That's the median of the bottom half, not including the actual middle number. Now I'm going to go to the top, and I'm going to find the median of this top section. And the median of the top section is right here at 29. So I have my 5-number summary, and when I go to make my number line, I need to have it evenly spread, because number lines should always be evenly spread. And I have to have the largest number all the way down to the smallest number. So I need to go from 18 to 30. So I could probably go by ones. So let's make a nice straight number line. And it has to go 18, 19, 20, 21, 22, 24, 6, 28. Oh, okay, so I went much further than I needed to, so I can erase all this right here. All right, so now I put 5 dots like floating up in the air to represent my 5-number summary. So I put a dot floating up at 18, I put a dot floating up at 23, 25, 29, and 30. Now, the way that you make the box is you connect Q1 and Q3 in using a rectangle, and then there should be a dot in the middle. That should be the median, and you make a line down that, and that's the box, and it's called the box and whisker because then you connect whiskers over to what we call the extremes, or the greatest and the largest. And this shows you the spread. You see, each section represents 25% of the data. It's set up into quarters. So you can see that 25% of the data is squished into this tiny little whisker over here. But there's a nice big spread down here, so maybe, this is a big range for an equal amount of people. So we've got a squished 25%, which means that it's clustered very closely together. There's a lot of data over there. And then here, there isn't a lot of data clustered together. It's nice and spread out. So that's one thing that you can do with a box and whisker plot. Now this is what I was just mentioning. Each section represents 1/4 of the data, right? I mean, obviously this box represents a half because it's 2 quarters. But each section represents the same number of items. So if you have a long whisker, it means that you're spread out. If you have a short whisker, it means that you're clumped together. If you have a long section in your box, it means it's spread out. If you have a short section in the box, then it means that they're clumped together in that range. Now, something else that you can do to measure the variation for the data is use this thing called the interquartile range, or what we abbreviate as the IQR, interquartile range, which is the difference of the Q3, the third quartile, which is the median of the upper half, and the first quartile, which we know is the median of the bottom half, right? So the range of this box from this spot right here to this spot right here, this box represents the interquartile range. And it represents the middle 50%. So like if you want to say, how do I compare to the median? If you're in that middle 50%, then you can consider yourself close to the median. A lot of times, if we talk about dreaded state test scores, if you look at those results, they'll give you a range that you belong in, and all the kids in that range are pretty similar, and that's kind of like what this is. If you're in the box, then you're pretty similar to the median. Next thing we have to do is to interpret or answer some questions given a box and whisker plot. So we've got this box and whisker plot, and it represents the lengths of songs played by a band at a concert. So the shortest song is 160 seconds. That's a little over 2 minutes. The largest one is 300. That's a 5-minute song. It says to find and interpret the range. So the range is just the largest minus the smallest. That would be 300 minus 160. So the range is 140 seconds. And so what this means is that the song lengths vary by 140 seconds. So the longest song compared to the shortest song is a difference of 140 seconds. Now we have to describe the distribution. So that's talking about the whiskers in the box. So 25% of the data, or the songs, are 160 to 220 seconds. Then the middle 50% of songs are 220 to 280 seconds. And the top 25%, those longest songs, are 280 to 300 seconds. Letter C says that they want us to find and interpret the interquartile range. So I told you interquartile range is the difference from the top of the box to the bottom of the box. So the interquartile range is 280 minus 220. So that represents the middle 50%. So the middle half of the songs are within a minute of each other. And the last one is, are the data more spread out below the first quartile, which is the bottom whisker, or above the third quartile, which is the top whisker? So obviously the bottom whisker is much longer than the top whisker. So they're more spread out in Q1 because of the longer whisker. You can take a moment to read this top section. It's pretty self-explanatory. What we just had was a skewed left box and whisker plot. You could also have a symmetric where it's nice and equally balanced, or the opposite of what we had, which would be a skewed right. Another thing that you can do with box and whisker plots is you can stack them, and you can use them to compare data. So for example, we've got this picture, and it represents test scores from your class and your friend's class, and we're going to answer some questions about how the data compares. So the first one says identify the shape of the distribution. So if you look up above, your friend's class looks very symmetrical and your class looks skewed left. And the last question says which test scores are more spread out. So the range and the interquartile range will help us determine that. So pause the video. I want you to find the range of your class and your friend's class, and then also the interquartile range of your class and your friend's class. And then once you have those numbers, we'll answer the question together. So for your friend's class, both the range and the interquartile range were larger, which means even though they're more symmetrical, their grades are more spread apart. So if we had to talk about it realistically, your friend's class has an equal distribution of values, and it looks like at your class, like most people scored up here, and then there were a couple people down there who kind of skewed the data. So that would be how you would think about it in a real life situation. If you have any questions, write them down and ask me when you come to class.